Sweet. Thank you so much to all our panelists for joining and all our attendees for being here. We're going to rely on you for a lot of the crowdsourced questions. So feel free to use the Q&A to ask questions to our panelists. The agenda for today is to discuss the bumpy road to AI research, by which we're basically getting at there is a side that you actually see as outsiders, and you and I both see as outsiders, and there's a side that actually exists for doing AI research. And we want to sort of normalize the discussions that happen when you're actually doing AI research and the experiences you have when you're going through this life cycle of projects. To start off with our host, our panelists for today, we have Professor Sam Bowman, who's a professor of linguistics, data science, and computer science at New York University. We have Kianté Brantley, I should say Dr. Kianté Brantley now, who is a PhD candidate in computer science at the University of Maryland, College Park. We have Professor Andrea Jones-Rooy, professor and director of undergraduate studies at the Center for Data Science at NYU. We have Dr. Sarah Shugars, who's a faculty fellow at New York University, research fellow at George Washington University, and computational political scientist. We have Dr. Yi, who's a software engineer at Google, PhD in computer science from New York University. And we have Yuri Zemlyansky, who is a PhD student at the University of Southern California, formerly a research scientist at Facebook. So before I go around and ask you all to sort of introduce yourselves, I'm going to add one question to the introductions as well. When you're telling us about yourselves and your journey in hopefully a minute each, could you also add the high point and low point in AI research that you've experienced in your careers? And I know this one wasn't shared with you, so I'm very curious about the answers. Can we start with Yuri and go around? You can tag someone to go after you.
Sounds good. Well, hi, everybody. Just a bit of history to highlight my journey in AI. I got a bachelor degree from St. Petersburg State University in Russia, and then joined Facebook right after. At that point, I really was not sure what I wanted to do, so I was just trying to see something interesting. I work in an anti-spam department, but then was very lucky to find and join the newly created machine translation group, which was roughly my first serious machine learning experience. We were one of the first in the industry to switch to neural networks models that we use in production. However, after a few really fun years, I decided to focus more on the research work. So I started my PhD at the University of Southern California with Professor Fei Xia as my advisor. Currently, I'm working on text understanding and text representation, memory augmented network, and finishing writing my thesis. So I had a pre-defense a couple of months ago, and I'm working part-time at Google Research right now. So high and low points, right? So this is a tricky question. I like to believe that currently I'm at a high point. Like, so all these PhD years are slowly building up to something that I'm getting more and more excited at which position I am right now. Regarding the low points, I think it was during maybe my second year, during my PhD, I decided to switch a topic. So I was working on a dialogue models during my first year as a PhD student, but then I decided to switch to more towards text representation models. So BERT model came up and I was very excited, but because of this switch, I think I not wasted, but it was a kind of tough time. So I spent maybe a year without publishing, trying to figure out what are good problems that I can work in the lab. Yeah, hopefully I recovered since that point. Next is Andrea, please.
All right. Hi, everyone. Thanks, Yuri, for the tag. Great to be here. As advertised, I direct the undergrad program here at NYU for data science, and I teach 2 data science courses. I teach our intro course called Data Science for Everyone, which is for students who've maybe never even written a line of code in their entire lives or just heard about data science in the news and are curious what it's about. And I also co-teach, I co-teach it with Professor Shugars, who's also here, sorry. And I also co-teach our most advanced course in the series, which is on using text as data. And we also have another segment on reinforcement learning that my colleague Angela Radulescu does. And so my way into This field has been via my PhD in political science with a focus on complex systems from the University of Michigan. And there I got very into using text as data, very rudimentary, I think, compared to what Professor Sam Bowman is up to, but natural language processing skills and techniques to make sense of texts related to what's in the news. My focus was on China and the Chinese media. And so I did a lot of text analysis of what sorts of things they were saying in their media compared to other countries when it came to big international events. And from there, I found my way more into the field of data science more squarely. I would say the highlight might have been when I realized that data science was my ticket out of, nothing against political science, but it was my ticket out of focusing only on politics and political data. I've been one of those people who's interested in a million different things, and data science and complexity, but data science is a field that really embraces multidisciplinary perspectives, and I get to play with data sets from all different areas. And I do a lot of consulting work, so I work with folks in the quote real world, and I get to do lots of stuff. So that's a big high point. Low point would have to be the time, and I think this is a pretty privileged low point, but it would have to be the time that I was talking to a consulting client who was hoping to use this machine learning model to predict performance evaluations for their employees so that they wouldn't have to sit around like humans and say, did this person do a good job? We could have a computer do it. And I said, well, how do you know those predictions are any good? And someone in the room, a very senior person at this big global company, turned to me and said, but how could it be wrong? It's data science. And I was like, oh no, we need to communicate what's going on here. Not that it's not informative, but we have a lot of work to do. So there's a low point for you. Oh, Professor Sam Bowman, let's hear it.
Cool, thanks. Yeah, so I had a sort of a direct but also very roundabout path into AI. I've been interested in sort of themes around AI and computation and cognition and cognitive science for a long time, since sort of early undergrad. But I wound up doing my undergrad and also all of my graduate training in linguistics, doing kind of computationally informed stuff more on the science side, and really only kind of in the end of my PhD and then as faculty moved into what I think would more firmly call AI research. So most of my career as like an AI person has been as a professor. And yeah, I think this is maybe a vague answer, but I think that the high and low point has been this kind of realization over the last few years that like, oh wait, there's something at stake here. That a lot of the technologies around language and natural language processing that people like me have been studying as this sort of fun scientific project for years and years, that had like some incidental little industry applications, suddenly works really, really well. And you can suddenly build a lot with it and make a lot of money. And this means both there's these incredible opportunities showing up as an academic who's sort of doing public-facing research, I have a lot of opportunity to shape that, but also it's much more dangerous. There's also many more ways these things can go wrong in ways that impact lots and lots of real people. So suddenly the stakes got higher recently. Oh, maybe I'll tag Kianté.
Can you hear me? Hi everyone, I'm Kianté. How do I get into AI? So when I graduated high school, I got a job at Department of Defense. And my high school is more like a trade high school. So like you take up a trade and it's geared towards you to go into the workforce. So I got a job out of high school at Department of Defense, and I was in a development team. And the team itself was like sort of like a startup. So I took on multiple roles. So one month I was a DevOps person, the next month I was like hardcore software engineer, the next month I was doing like system testing, and next month I was doing AI development. And I was like, oh, this is really cool. It was really cool. And we started collaborating with people in the research department. And I was like, I don't understand, like, why, there was this guy named Greg that we work with, and he had a PhD in topology. And I was so confused. I was like, you have a PhD in topology, but we're doing research in AI, and all these things were like, it's just mysterious to me. But I found the people in research to be really, really cool and down to earth. And I kind of like the culture a lot. And fast forward, Greg became my mentor for 6 years, and he kind of got me like into like doing research in AI. So that's how I started. The research that I did at DoD was sort of like for networks and things like that, like computer security. And it wasn't really that exciting. So I quickly transitioned to doing research in some other sector. That's how I got in. Highs and lows. The high point is like during my doing like the system and the journey in which doing a PhD and like the skills that you learn, because you basically have a lot of time to fail. So like my PhD is just tons of failures. Like you may see papers and it's like, Kianté has papers. But if you only know how many times I failed, like the first project that I've ever done took me a year and a half, and guess what? It didn't turn into a paper. In fact, we wrote a paper and we had proofs. They all were wrong. We had code. The code was wrong. The whole paper was a fail, right? But during a PhD, you can do that. But like now, like I'm done. I graduated. So the low is like now I have to be an adult. Like I can't like do a lot of those failures anymore. Like I really gotta like know what I'm doing. So that's my like high and low, at least perspective of where I'm at.
You want to tag someone?
Sarah.
Great. Well, hello, everyone. I'm really excited to be here, and it's been really interesting hearing everybody's stories. So for me personally, first of all, I'm first gen to college, which I think is relevant to my journey because like when I went to college and also when I chose my major, I feel like I had no concept of what I was doing or how it would lead to a career. I was just like, I don't know, this is something I took in high school and it seems interesting. So that's all my way of saying that I studied physics as an undergrad. And this was in an undisclosed year where it was the internet technically existed, but not in the way it does now. And so I learned to code because basically a professor gave me like a thick textbook on C and was like, good luck, go. And that was all the instruction I had, which many people have successfully learned to code that way. I'm not sure I was one of them. So by the time I graduated, I was like, I'm done. I need a break from physics. I need a break from this kind of work. And ended up going in a totally different direction, doing more like communication work, worked in nonprofit for a long time. And then sort of, especially as computational, sort of the computational field started to grow. And I think relevant to some of Professor Bowman's points about sort of the many concerns around AI, I got increasingly interested in bringing together sort of the social science work that I was doing with the like computational quantitative training I sort of technically had from my undergrad years. And so I went back to school for a PhD and sort of brought those two things together, and sort of it's been an ongoing journey of finding my path, which I also hopefully is helpful to share, because I think often younger me thought everything had to be very linear, like you do this thing and then it leads to this other thing. Like at any point in time, I just like do the interesting thing in front of me, and I had no plan, but it seems to be working out pretty well. In terms of highs and lows, I think I was thinking something similar to what Dr. Brantley said, where I think of a lot of the work I do is very similar in many ways to like playing video games. So like when you see people like coding online, they're just like hacking away and enhancing images or whatever, and it's crazy. And so if you're not used to doing this work, you might have the conception that that's what it looks like to like do AI. But the reality, and here's the video game metaphor, it's like nobody sits down and plays a video game from beginning to end and just like beats the boss on the first try and makes no mistakes. Like you're constantly like being killed and restarting your game, and you just sort of like make these little incremental progress where you're like, oh, I made it a little bit further this time and made it a little further. Sometimes you make a mistake earlier, and there will be more failures in your life. And it's just sort of, it's a constant process of failure, but then also like you have these really exciting things that happen. So I think the lows are like when I'm working on a project, I personally actually like schedule time into my project where I'm like, these are the days where I'm going to feel terrible about myself, because for me, at least that sort of helps me manage my life. But then I also am like, oh, these are the days where like, I will feel good, or like take time to celebrate those successes. And Professor Yi.
Hi. Yeah, thanks for sharing, everybody. And yeah, very happy to be here to share some of my experience as well. So for my journey, I started off as a biology undergrad. I guess like growing up, I've always kind of been a nature person. I like, living things, when you were a kid. And then so for undergrad, I chose biology, and then I ended up working in a developmental biology lab, doing wet lab work, studying the lateral line development in zebrafish, embryonic lateral line development in zebrafish. Those old days when you have to do pipetting on a bench and stuff like that. So I was having a lot of fun with it, but like part of what I did there made me realize, it's very limited when you're just doing wet lab bench science, because at the time there was a project that I had to do some, we get these large scale and like genome sequences from one of our projects, and then we had to outsource this to these bioinformaticians to analyze our data, because at the time I personally did not know have these computational knowledge to analyze those data. So for me, that was kind of a turning point for me to say, okay, for my career, I probably not want to just do wet lab bench science, because it's very limited as to what you can find. So so after undergrad, I joined NYU, the biology PhD program. So doing, bioinformatics and computational biology projects. I stayed there for about 2 years. I was very happy there. But eventually what I realized is that was around like 2015, 2016. So like the neural network methods and machine learning methods start to develop a lot. And then we start to see more and more papers and then research coming out where people are trying to apply, those neural networks that has been established in NLP and then computer vision field and applied it to biology. And I want to, be part of that effort. So at that time, I felt like even though I was doing bioinformatics and computational biology, it wasn't like machine learning. So I want to do a little bit more, learn more about computer science, and then have like a just systematic training in that area and being able to work with more ML focused people. So after 2 years staying in that program, I decided to drop out of that program and started another program at the CS department at NYU. So here I studied I recently just graduated from CS, and then I was co-advised by Rich Vanol and Kianté. And then for my PhD, I worked on like computational genomics, and then also developed ML methods for modeling transcriptional regulatory networks. And then during my PhD, I also did like, I guess, 2 internships under Alphabet. Both are related to computational biology. So first was at Google, the genomics team at Google, and also the next one was at the science team within DeepMind, before eventually I took on a full-time offer at Google very recently. And then right now I'm working on like privacy preserving technologies at Google. So in terms of my high point, I guess since I just graduated not too long ago, I guess one of the high point was, finishing our PhD, getting your degree, and also being able to land a job you actually, I was very happy about, because it's just, it took me a while to go from a bench scientist to, a programmer sitting from a computer doing machine learning and then AI related research, and then to actually being able to land a job and doing exactly that. So it was, realizing that the path I took eventually got me here. And also, I think in grad school, a lot of what I worked on was basic science that I guess in the long run will contribute to the development of this field. But for a while, I feel like I wanted to work on more like projects that are closer related to people's life, and that can being able to impact people's life in a shorter time frame. So yeah, I'm very glad that the team I joined eventually right now, I'm able to working on something that that can actually impact people's lives in, I guess, maybe a couple of years if things work out. Yeah, I guess low point for me, I guess PhD was hard. I guess for me, it was a lot of times when especially because I went through this transition from one PhD to another. So there were some times where you were like, why did you do this to yourself? Especially when things get hard and then your project doesn't work. Why do you do this to yourself? You just stick to your original path. You probably will graduate a couple years sooner. But I guess the lesson I learned from that was just don't get these negative feelings. Don't have these negative feelings consume you. Just continue doing the good work you did. It's okay to make mistakes and then fail sometimes, but eventually things will work out.
Sweet. Thank you. So we've got a bunch of insights already from a lot of people, and for the applicants, for the participants, especially, like if you want to start posting questions in chat, please feel free. But I'm going to throw out rapid fire questions at all our panelists until we start seeing questions there. Especially, and I would encourage people who are not from traditionally AI related fields for you to break into AI if you have specific questions. I think we have a bunch of people here who highlighted that journey, and you can ask them a lot more about that. So please feel free to direct your questions at panelists, and we're happy to take it. Harvinit's already on chat. Until then, a couple of quick, and I think these can be rapid fire because they're mainly like getting opinions. So I want to start off by throwing out this question, like, how is the field of AI? And bear in mind that this is particularly with respect to these students who are, I think, largely aware of AI research through, I don't know, maybe social media channels, maybe what's published in the news, maybe what sort of awareness they have is not necessarily just purely scientific. So how is the field of AI different from what it's portrayed by the media? And what would you say are like some, do you have any comments on the way it has grown?
I could start with something maybe, well, it seems, I won't explain, I'll just say it. All right, I was going to say it's too obvious, but I'll just say what it is. Mine is that I think that there is a lot of emphasis on, and rightly, the programming and technical sides of AI, and that's supremely important. They're extremely powerful tools, and it's a big reason that we can do all the awesome things that we do. But I think there's not enough emphasis in the general portrayal of AI and related fields on the role of things like creativity and imagination and substantive expertise in particular fields. Too often, I think we think of AI as a fancy hammer that can come in and suddenly turn our house into a mansion, when really we need good old-fashioned architects and people with an eye for design. That's a bad example. I don't know much about building houses, but generally speaking, AI will benefit from having everyone play a role. And I think a lot of really smart, thoughtful experts and creative people are either intimidated or feel they don't have time or energy or skills to learn programming and think that that's the barrier to getting involved. And I think the reason for that, I won't give you a whole treatise, but the reason for that goes both ways. On the one hand, I am not someone who grew up programming and was very scared of math for a long time until it was forced on me in my PhD program. And then I think if I can get it, anyone can. But I think there's also a bit of a hubris we have once we get the programming side of things, where we think, well, they couldn't possibly understand what I'm up to because I'm typing, as Professor Shugars said, in that kind of like Mr. Robot style depicted hacker online. And I don't have time to talk to people who just, work with other humans and stuff like that. So there's some hubris and some fear, but the more positive version is AI needs a lot of creativity, imagination, and expertise, not just amazing programming skills and things like that.
Sounds good.
Thank you.
To throw another question out there, particularly for Dr. Shugars and Dr. Yi. What sort of challenges, given that you came from different backgrounds that you just highlighted, what sort of challenges did you face in finding a path into AI from traditionally non-CS fields?
Yeah, so, oh, go ahead.
And, sorry, to interrupt you and add on top of that question, I think we have an candidate, someone posted in the chat. Does one also need to be exceptionally good at math to succeed in AI and ML? There you go.
Oh, those are both really good questions. So I guess I would say for the first question, going to what Professor Jones-Rooy was saying, like I think there are a lot of paths within AI. So like there will be some people who go into AI and I don't know, maybe they do code like people code on TV and they're just, elite hackers or whatever. I don't think so, but But they're also like, you need people who have domain knowledge, who can understand how to interpret systems, who can understand how to interpret your results. And so a lot of my work and then my entry into AI has been sort of having a computational background and like being familiar with these tools, but I also like, I do a lot of work with text, but I'm not gonna be the person who like develops the next BERT or whatever. I'm going to use those tools to have innovative insights into human social systems. And that is okay, and it is good, and it is a good fit for me and the type of career I want to have. So I think a piece of it is figuring out sort of the range of possible careers within AI, what type of work do you want to do, and sort of where do you fit based off your own skills and interests and background and experience and all that stuff. In terms of the exceptionally good at math to succeed in AI and ML thing, I think this is partially a tricky question because like a lot of these methods are, implemented in other things. So one of the dangers of AI is that you just go and you're like, I scikit-learn did this thing and I got a result and therefore now I know the truth. Whereas again, that's where you need to be able to interpret things. So I think, again, it depends a little bit on sort of where in the universe of AI you are. I think you need to understand math well enough to be able to understand the conceptual underpinnings of the specific equations and things. So, I think a lot of it sort of has like linear algebra underlying it. Doesn't mean that you need to like understand linear algebra and be perfect at it, but you need to get used to understanding what a matrix is, thinking about what it means to represent data in this high dimensional space and to sort of like to project things into a lower space or multiply matrices together. You do need to have some understanding of it, but you don't need to be like, again, like you walk up to the chalkboard and you're like, yes, I know the missing number in this equation. Like you don't need to have like superpowers, would be my take.
Yeah, so for the math questions, I guess my answer would be probably similar to Professor Shugars, which is you probably, if you're just starting out and then you don't have a math background, you probably don't need to be good at it right off the bat. But as long as you're willing to learn, you're willing to, for example, go through some online resources to get to learn linear algebra and discrete math, or courses like this to get yourself familiar with the concept, to not only know how to use Kairos, but know how, for example, how convolutional neural network works, how different, how the math underlying different neural network architecture, things like this, it will help you in the long run. I guess that would answer the math question. In terms of my initial challenges going into AI, so as I said before, I only had a bio undergrad background, and then so I didn't realize that I want to do CS or math related or computational research until later in my undergrad. So at that time, it definitely one of my challenges was having to be able to pick up programming and then pick up the math that I didn't study during my early years in the undergrad in a very short, relatively short period of time. In order to, have, I guess at the time, have a good enough application to apply for grad school and then that kind of stuff. So I guess the good news is that, from the last couple of years, there have been so many more online resources coming up, not only Udacity, Coursera, MIT, OpenCourseWare, those this different online resources are coming out where you can also, like NYU AI School, these kind of courses you can take to even YouTube. I definitely feel like, a lot of what I need to learn in grad school, I learned a lot of them from YouTube just by, looking at different people's lectures and then learning different concepts. I guess that was my big challenges, but I'm happy to see that things are getting easier for people just starting out because there's just a lot more resources out there these days.
I possibly could add a few more words about like whether one needs to be exceptionally good at math and programming. And so my undergrad was mostly in math from Russia, and honestly, I think psychologically it hurt my journey in AI a little bit, because when you work with math, you kind of trying to find that extremely nice high-level structure that exists in the problem. Right? You're trying to find that a single equation that kind of explains how the whole system operates. And on the other hand, what I'm getting is AI is more empirical field, right? So it's more closer to maybe biology than to math, where you do some experiments, some of them work, some of them don't, right? But you theoretically explaining from the first principle why a neural network work, it's a very important topic, but that's not something that most of people in AI are working on. Another thing, what I think is probably most crucial is, as Andrea said, it's a creativity, right? It's trying to find problems that people hasn't addressed before, questions people hasn't asked. But the one other thing, I guess, is you can say it's, I mean, it sounds a little bit cheesy, but I think it's a passion. So when you're really interested in something, you don't need to be exceptionally good at it. So I know for like a couple of I know people in my university who were getting B in their optimization courses, but they were really interested. They went, they did research, they published papers on this just because they were interested in, right? So they had this, they allowed themselves not to be stopped by their progress in the coursework, just to do what they wanted. Yeah, so programming and math is just tools. That's not the end goal when you work in AI. So this is something you can pick up on as you go.
That's an excellent point, and that actually leads into this other question that we had, which was, could you tell us about a time when you were really excited about a project, but it panned out really poorly instead, which I think Kianté started out answering already. So you can pick up from there.
Yeah, sure. So I started my PhD, and like there's this like cool topic called reinforcement learning. I'm like, oh, this topic sounds super cool. My advisor's like, okay, Kianté, here's what we're gonna do. And like, mind you, I'm like a hardcore, so I did like hardcore software engineering. So like I'm like undefeated with any hack. If there's a hack and something to like do with programming, I will spend all hours to get it done. So my advisor says, Kianté, here's the project. I want you to go get the ROM and the engine from like these Super Nintendo Entertainment System games. And we're going to train a reinforcement learning model to like solve some of these games using some idea I have. And like, so he tells me the algorithm and I'm like, sweet. My advisor gives me the algorithm. It has to work. And we don't try it on anything simple. We don't try it on really small problems where I can really like test my code. I just go right to the game, like the game, the algorithm, and I just run it. And like, I'm like, this has to work. And I spent like an entire year trying to like debug and like fix things. And like, I'm like, this doesn't make sense, and trying to alter things and like fix things. And then finally, a friend of mine like joined the project, and he was like, oh, Kianté, like, let's just like drop this down to like a very simple problem to solve. And like, I run the algorithm, a simple problem, doesn't work. Like the algorithm is fundamentally just broken. And I was like, oh no, like my dreams of like having the algorithm work on the game. That was my first project. It just didn't work. Didn't work at all. But it was fun.
So I want to follow up with, we have at least 3 professors with us today. At that level, like when projects fail, how do you deal with this? And like, how do you normalize this concept for students that you're working with?
I can jump in on this. So one thing I found, so first, I mean, I'll just say most projects fail. If you're strategic and you're lucky, they fail really fast. They fail in a couple of weeks instead of after 6 months. But it's just it's an empirical science. We're exploring an area we don't understand that well, so that most projects fail. The thing that I found that makes this a lot easier to deal with, just a lot less of like a self-esteem hit, is just to really encourage research students, if they're in like the later parts of master's program or PhD program where you can devote a lot of time to research, to be doing 3 or 4 things at once, ideally with teams. So a lot of the students in my group maybe they're taking the lead on a sort of slow moving project with a couple other students. They're also helping out a couple of other students with a couple of different projects. And what that means is kind of like your whole self-esteem, your whole like image of your career isn't bound up in any one result. And so sort of canceling projects, switching projects, you get used to that happening every month or 2.
Yeah, don't put all your eggs in one basket. Yeah.
Yeah, I know the good thing is all right, also having big teams, when these projects succeed, they often are really great and exciting and we get cool results we can tell people about. But yeah, that's 10 or 15% of them at best.
Another thing,
Yeah.
oh, go ahead.
So I think sort of a corollary to that is that there's also some projects that like are particularly hard and you can sort of let simmer for a while. So I have a project that like I have been working on this for 5 years. It's 1 chapter in my dissertation. The other 2 chapters are published. It's something I actually had a meeting earlier this week about potentially turning it into a book. And it's something that I will continue to work on for probably the next 10 years. And maybe it will turn into something interesting. But I have to sort of intentionally be like, okay, that project is a high risk project and it's a very small percentage of my time, but it's something that I'm sort of interested in letting percolate as I'm working on it. And all of my other projects, I'm like, I'm getting something out the door, or I'm saying, nope, this is not going to work. It's going off the list. So figuring out how to sort of identify projects in those buckets and to not get too embedded in like, oh, I've started this project, I have to finish it or else I'm a failure. Like, nope, if it's not a good use of your time, take it off your to-do list because there are more projects to do.
I can also add a small point, sorry, to that one. That is, I got very spoiled by the academic calendar of like, oh, at the end of the semester, you've turned in everything and the exams are over and the paper's over and you're like, put a bow on your life. Like one of the things that I've had to embrace actually as a professor and practicing research is having these loose threads kind of all the time and thinking of that as a good thing, as opposed to like killing yourself at night and saying, I haven't finished this chapter or I haven't finished this, whatever. But the other thing I was going to say is that I like to help my students, and this depends on what kind of research you're doing, but I like to encourage my students to see if they can set up their projects in such a way that it's a no regrets project. So you do something and you say, wow, this is consistent with the main, leading thinking in this area, or you do something and say, wow, it's not, but both outcomes are information. This doesn't necessarily work if you're trying to come up with a method that solves some problem because you either solved it or you didn't. But I do try to say, even if you think of it as a failure and you can't publish it, it's still, you've learned something. So it's not so horrible. There's a whole other conversation to be had about the importance of sharing null results and being more public about, hey, I tried to build this thing this way and it didn't work. And finding a good place to let all that stuff live so we can learn from each other's mistakes is something that I'd love to see this field and a lot of scientific fields do more of as well.
Yeah, the idea that the general idea that we're talking about is called sunken fallacy.
Yes.
So the idea is that and it's like the first thing you learn when you do research. Just because you've synced time into a project doesn't mean you should continue to sink time into the project. Once you get to a certain, you should always evaluate on an ongoing basis of if it's worth it. And it's called the sunken fallacy. Yeah. Mm-hmm.
Yeah, one thing I want to just quickly add on to that was, I guess if you're starting out as if you just get into grad school and then you're in your early stage, finding the advisor that's right for your style, I think is also important. I think there are advisors have different style. Like from a graduate student perspective, there are advisors who are a little bit hands off of things, who give you a little bit more freedom into choosing your own project, choosing the directions you want to follow up on. And then those, I think those advisors would be very useful for students who have a lot of creative ideas, who want to have the creative freedom to do whatever they want to do within the project overall project theme of the lab. But if you're just starting out and then you're a little bit unsure of which directions you want to do, you have less, you don't have a lot of domain knowledge, you would have less intuition as to which direction would go for. You probably want to look for an advisor that are a little bit more hands-on, who can point you at the right things when things look like would get wrong. I remember it was one small things that I took Professor Bowman's course several years ago. There was a final project in the class, and then me and my teammate went to his office and was like, this is the project we want to do. I mean, knowing that I knew very little about NLP, and then that course was about NLP. And then Professor Bowman was like, yeah, I don't think this idea is going to work, but you guys can try it. And we tried it, didn't work, but it didn't really matter because we still learned quite a bit from that course. It was a very, 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 very useful course, actually. You know, whether your project fails or not, giving yourself a time frame. Okay, I want to work on this for this period of time, and if it's extended, like significantly exceeds the amount of time you plan on, probably you should talk to other people, your advisors, and other people to see what are the alternatives you can do. Things like that.
I love the conversation flow, and I think there's a perfect question for Yuri on chat, given that you mentioned you got into Facebook after your bachelor's. Maram asks, it seems that most people moved on to further their studies. Can one still do these opportunities and be successful with a bachelor's degree? Like, how would you comment like what you did, or if someone were to do?
Yeah, absolutely. I mean, in my lab, right, where in university where I'm studying right now, I think more than half people in the lab don't have a master's degree. They only go to a PhD right after the bachelor. And I think the same thing holds for Facebook team I was on. So quite a few falls just out of university and were brilliant. So if this is a question is, I mean, I wonder if this is a question on whether master degree is required, right? Or whether you can just go directly from or like how much you can achieve if you have a bachelor degree. And I guess most of the time it just helps like whether you know what you want to work on, right? So if you know that you want to go and do some applied machine learning, then you don't necessarily need to go and get master degree, right? So there are a lot of opportunities in industry where you can find and slowly build your expertise from a hands-on experience. You can also try to just apply to a PhD group, to PhD position. It is challenging, and I think we'll discuss further some caveats to this, but it's also possible. I think that like most of the time, getting things like a master degree can help you finding out what your passion lies, right? So you can take different courses, you can try machine learning, you can try systems, security. There's a lot of things in computer science. And arguably, maybe I really wish that I actually did a master or something like this, because when I went to Facebook, I have no idea what I want to work on. I knew I wanted to have something challenging, something that like excites me, but I knew no idea what it is. And yeah, I was lucky that I found something like that while working in industry already, but that doesn't mean it's an optimal course. Yeah, I'm not sure I answered the question, but I did answer something.
I think that was really helpful, and we can always have a follow-up if that was
Sam can go. You can go.
Oh, thanks. Yeah, just a quick observation. I think this is true. There's a lot you can do post-bachelor. I think getting access to opportunities, getting access to sort of a good first job does unfortunately depend a lot on what your resume looks like, including a lot of the time just kind of what program you were in. And so one use for a master's, and this isn't a great situation, is if, all right, you've got the skills, you know what you want to do, but just you're not able to get the opportunities that are most exciting, you're not able to sort of find the next step, that can sort of get you a chance to sort of be in a context where you have better connections, or have easier access to the sort of really high-paying, interesting, fun, prestigious jobs.
Yeah, I was gonna say basically like the degree is for people who don't know you. So because for people who do know you, they know your skill set, they know what you can do. So if you apply for a job, then those people who don't know you, so you have to prove yourself. So you can it's definitely possible, but the path is not as clean as having a piece of paper that says like, here's what I know, for people who don't know you.
Yeah, if you're lucky, actually, even a bachelor's isn't necessary. I know I'm going to be working with someone on a project coming up who's leading a large research team at a research institute who started doing professional research work when he was like 19 or 20. So it takes very, very lucky combination of connections to get there, but even that is possible. So.
That's actually pretty cool. I want to switch gears a bit and ask Professor Shugars about like this question, like in what ways do you think the AI community has succeeded in welcoming people from different backgrounds? And in what ways do you think we're still lacking the kind of efforts that are needed to improve diversity that is clearly not here?
Yeah, this is a great question, and certainly something that beyond the AI community, many communities struggle with. So we'll talk about AI in particular, but it's a much broader, one might say, systemic problem. And I think there have been a lot of good efforts made recently to increase diversity, to articulate a care for diversity, but at the same time, I don't know that any of what's currently being done is enough. I think there's also a lot of gatekeeping, and in many ways, this goes back to the question about sort of how good do you need to be at math, where, there are certain demographics of people who are more likely, like it is shown that they are more likely to apply for jobs and opportunities, even when they don't have the actual credentials. So like cis white men, for example, tend to put themselves out there much more often than people of other demographics. So if you have this idea of like, oh, to be good at AI, I need to like be an expert at math and an expert at coding, then you're much more likely to sort of intentionally remove yourself from that space. And there are demographic implications to who chooses to remove themselves from that space. Then it's made worse by the fact that when people do put themselves in that space, if you're surrounded by what I like to call methods bros, who are like, yeah, so then we just, we take the linear transform of this, and they intentionally use like the biggest words possible and explain things in totally inaccessible ways, because then they sound smart and you don't want to ask questions because you'll feel stupid. And like, really, they're like, oh, I did a linear regression and I counted to 10 or something. Like the actual method is often not that complicated, but they explain it in this way, so it's all flashy and cool. And then if you're going into that space being like, well, I don't really feel like I belong already, and like, I'm not really good at math, that's just confirmation that like, you don't belong there. So, there's definitely overt issues of, overt racism, overt sexism, lots of issues like that. But I also think there's serious issues in these more implicit things, and sort of the cultural definition of like being good at AI means like being a methods bro, which then means like being a cis white dude, and not just any cis white man, but like a dude, bro, whatever. Like, so I think there's just a lot of work that we can all be doing to improve that culture, and to make sure to talk about our methods in accessible ways, and to define the terms that we're using and things like that, and make sure that there's always space to ask questions, because people will always have questions and that's okay, and that's normal.
I think as a gift to the students who've stayed on this all this long, we, especially those of you who've sat on review committees, these are applicants who are probably going to be applying to grad school in the next couple of years, at least some of them, and others will be applying to other places. But like, what are the top 2 or 3 things that actually make you notice applications? And in what ways could they, given the current climate, differentiate themselves from the rest?
I have some thoughts on that. Oh yeah, Sam, you go ahead.
Yeah, so I'll give the very cynical answer and the less cynical answer. So the very cynical answer is that actually, so I'll talk mostly about PhDs. I'm mostly involved in PhD admissions. I wonder if Andrea, you can say more about the master's side. For PhD admissions in machine learning and AI programs, it's gotten really, really competitive. So no matter how good you are, there's a lot of randomness, and this is unlike a lot of other fields. So it's often the case that maybe you're sort of, if you're really good enough in chemistry or something, you can be pretty sure you'll get into a reasonable PhD in chemistry. That's sort of not true anymore in AI. And having just really good credentials helps in that circumstance. So if you've already done a lot of research, if you've already worked in other prestigious universities or companies, that's kind of the only thing that can make it like even pretty likely, and even then it's risky. So it's just, there's a lot of uncertainty. You should never kind of count on getting, into a machine learning AI PhD program, which is not great. If you can find other ways in through other kinds of PhD programs, there's other kinds of professional experience, that's super helpful. And if you can find a way to do research that will help you prepare for a PhD, doing research in sort of excellent context, prestigious context, does make it easier. So that's the kind of unfortunate, just logistical reality of the field right now. In terms of, I think, what people look for and the kinds of skills to focus on and thinking about when you're applying for something very competitive like a PhD, I think it's probably similar to a lot of industry positions. It's worth keeping in mind that the field changes really, really, really fast, and it's changing faster than ever. And so, and as several panelists have said earlier, it really involves a pretty broad mix of skills, not just math and programming. So I think proof that you're able to start to learn a new thing, learn it relatively quickly, and get really good at it for a wide variety of things is super, super valuable. And that can be tech related, that can have nothing to do with tech. That's actually exciting to see in an application. It's also nice to see people.
Can you give an example? Can you give an example for people? Sorry to put you on the spot.
Yeah, that's tricky because it takes so many different forms.
Like hackathons, like if someone says they went to a hackathon and they talk about the
hackathons can be good. I think unstructured stuff is even better. I think it's something where you're not in a competitive environment. You're really just trying to do something where you're like, hey, I want to create a program to teach 2-year-olds archery. No one really does that. There's no reason anyone would do it, but I'm going to figure out how to do it. And the 2-year-olds that I'm teaching are good at archery. Like that would be great to see. And that's maybe more useless. It'd be cool if you're actually accomplishing something worthwhile along the way. But just a skill to sort of pick up a totally new undefined problem and do it well is exciting. It's valuable to see a mix of experience doing tech things where you kind of know what programming is like, you kind of know what working in a technical team is like, and also you know what it's like doing kind of more professional work that involves dealing with other people, sort of working with teams, organizing people. I think those are both the hard part. And writing skills. Doing a PhD in particular involves a lot of writing. I think this is where having a minor or dual major in a humanities field can be super useful, or if not, just kind of writing a blog, writing something that that makes you sort of think about what it means to communicate clearly can be really impressive.
I can say a few words if it's helpful.
Yeah,
I'll try to keep it short on the master's side of things. Swapnil, I think you've heard me rant about this on a separate panel we were on together, so feel free to just say it along with me. But I sit on the admissions committee for the master's program in data science here at NYU, and Professor Shugars has been on it with me as well. And I will say, similarly to Professor Bowman, one of the biggest things you can do to stand out is to proactively do work that shows initiative and creativity and interest, and that unstructured work goes a lot further in my mind. This is my view and things we talk about on our committee. I'm obviously not speaking for all data science master's programs everywhere, but I'm a lot more impressed if you say, hey, I'm super interested in economic inequality, blah, blah, blah. So I built a thing to and here are my results on GitHub or whatever, or I wrote it up or shared it. It doesn't have to be a published paper, just something that you did that shows some initiative and your ability to handle thinking about applying data science to the real world and navigating that messy process. That goes a lot further than what I see a lot of, which is students who say, I'm so interested in data science. So therefore, in addition to all these courses that are really related to data science and AI, I also did this Coursera thing. I did hackathons, I did datathons, I participated in these other things on Kaggle and this and that. And that's better than nothing. And I appreciate that that takes a lot of time. But if you have the time and resources to sit through a Coursera course, I'm much more impressed to see not that you're good at taking a course passively, somewhat passively, it's that you can actually produce data science research and apply yourself in that way. So that's, if you have that spare time, do your own projects as opposed to these sorts of things. The other thing I'll say to data science master's applicants, sorry, I keep saying data science because that's our program, but AI more broadly, is your personal statements should not begin with, I've been obsessed with AI since the day I was born, or something like data is the new oil, or blah, blah, blah. This is why AI is so great. And you also shouldn't say, I want to go to your program because your program is so great. Let me tell you about how your program is great. The idea is to tell us why you you personally want to keep going in this field. What is it that interests you about the field? What do you hope to do with these skills? And really be honest about it. And you know, when people do go that far, they say, I want to work in fintech, and you're like, okay, but maybe you can be more interesting. There's some of my own bias, right? So don't be shy about really selling yourself and saying genuinely what you hope to accomplish. Don't just try to flatter and sound like you're the most passionate person about AI because everyone else sounds like that too.
I think the last question I want to go for is a two-liner from everyone on your take on the future of AI research. We can start with Ren and go around the room.
Two-liners of future of AI research. Since I joined Google, I started working on privacy preserving technologies. I definitely think in different parts of AI, different domains of AI application, I do think privacy is a more increasingly concerning topics that people should care a little bit more on. For example, this is not a two-liner, sorry. For example, what I worked on in computational biology or health in general, there's definitely a lot of issues when it comes to sharing personal DNA data with big corporations, things like this. And then there's definitely a lot of other areas that is also very important when it comes to user privacy. So I guess that's I guess one thing that that I think is an important aspect of future of AI. Yeah.
Pass it over. Yuri?
Yeah, well, a lot of things happening right now in AI, and for example, NLP, where I'm interested in, and it seems like, so a lot of things has happened, right? So we have this BERT model that can analyze text pretty well, can perform a lot of the tasks, but the more you work on it, the more you see that there is a stark contrast between tasks that are rather easy to solve, and then the current models excel at solving them. And there is another area, black area of AI hard tasks, like things that include reasoning. And like, as long as you're trying to solve something from that area, your models suddenly stopped working immediately. And I think, so something needs to happen, right? So the current methods might not be extremely well at going from the tasks where you can already do something very well right now to something more like AI hard tasks. And yeah, my hope that within like future, maybe 10 years, maybe 20, there would be like another breakthrough that allow us to solve something much more challenging and much more exciting. Maybe it would be symbolic reasoning methods in combination of neural network, maybe something else, but I can feel like we're already on this border. I'm very excited about it.
I'll jump in. Yeah, I think this very clear trend we're seeing in some areas of AI that's having impact faster on some problems than other, but will probably be very clear in the next like 10, 20 years, is if we throw really simple neural network models at just tons and tons and tons of data, they acquire lots and lots of skills. They get really good at doing lots of things, but that doesn't necessarily come with doing the thing we want them to do. That's sort of taking a model that has a lot of knowledge, that has a lot of skills, and sort of figuring out how to nudge in the direction of actually doing the thing we want, doing it reliably, doing it safely, doing it responsibly, is going to be the hard part. It's less giving model skills, it's more figuring out how to express what we want in a way that a system can use.
I would just piggyback quickly on that to say my piece, which is more or less where I started this panel, which is to say that I really hope to see more effort, and I'm so biased because this is what I'm interested in, more effort into helping everybody understand what is actually going on in these models, as opposed to just deferring them to them and bowing down or dismissing as garbage because we don't agree with their output. I think a more thoughtful, nuanced understanding at a general public level about something like AI is increasingly a requirement and isn't just something that we can leave to the computer scientists.
I can go. So my thought on the future is that at the moment, it's like if we stand very far back and we look at like a map of AI, everything seems amazing, everything seems good. Like AI is great, but if we get closer and closer to the map, we'll see that there's a lot of holes. There's a lot of problems that are not solved. There's a lot of things that we kind of like turn a blind eye to. So my hope is that in the future that we attack some of these problems that exist from a very principled standpoint, and we come up with solutions so that we can like make progress on things that some more important problems that exist.
Yeah, so I think similar to what folks have said, there's a lot of excitement about the future of AI. There's so many cool things that we could do and so many exciting applications, but at the same time, you know, there's so much power that comes with AI, and as we know, with great power comes great responsibility.
I love that we ended this on that note. I think thank you so much to the panelists for being here. Thank you for your applicants for the wonderful questions, and thank you to the moderator. Yeah, sure. Thank you to the moderators. Yeah.
Thank you to the moderator.
Thank you to the moderator.
Thank
Thank you
you.
everyone for being here.
Thank you.
Yeah, thanks for showing up.
Thanks everyone.
Thanks, guys.
Bye. Thanks, everyone.
Bye.